Good morning, everyone. We are delighted to be here today at the Space Education and Strategic Applications Conference. My name is Greg Clements. I am in the Strategic Integration team at NASA's Office of the Chief Technologist in Washington, D.C. We're hoping to talk to you a little bit today about some of the strategic partnership work that NASA is undertaking. The other panelists, the real stars of the show that'll be with us, include Max Briggs, the iTech Program Executive and Entrepreneur Engagement Lead for NASA Space Technology Mission Directorate, Dionne Hernandez-Lugo, the Technology Utilization Lead in NASA's Human Exploration and Operations Mission Directorate, Nicole, or Nicki Rayl, Chief Technologist for NASA's Science Mission Directorate, and Ken Wright, the Innovation Lead for NASA's Office of the Chief Technologist. So let me share my slide deck and we'll get started with the show. Give a second for the slides to come up. I think everyone can see the charts. Okay, so I'm going to talk a little bit about NASA and partnering. NASA, from its very early days, we have worked in collaboration with industry and academia and other government agencies to peacefully explore, gain knowledge, and create innovations that kind of help our world. Our success is really enabled, and it's critical upon leveraging the best talents, ideas, and innovations that America and the world has to offer. Partnering is very, very important for NASA's success. We are currently undertaking a variety of different programs and activities in low Earth orbit, in our aeronautics work, with commercial space in the cislunar environment, discovering new things about our solar system, and even going deep space. And collectively, the four mission directorates, aeronautics, science, human exploration and operations, and space technology, are engaged in a variety of programs and activities to enable exploration. We have a variety of different programs that are going on currently. Obviously, we're still up in the International Space Station. We're doing a lot of commercial development in low Earth orbit. We're starting some precursor missions for Artemis to start bringing knowledge and capabilities to the lunar surface. We're doing robotic precursors to Mars. We're developing a lot of technologies to kind of solve those problems and challenges that NASA has. And we're doing space communications, making sure that we can communicate with all of these assets. One major place in space that we're doing work is in the International Space Station. So it has been continuously tended for nearly 21 years. There is an international crew, and the space station allows us to do science, technology, and innovation, and learning about living and working in space and creating capabilities that are not possible to do on Earth. We've established the ISS National Lab in 2005 to enable research and scientific and technological innovation. There is a link to the ISS National Lab to talk about how we are currently partnering with different activities and entities. NASA has developed technologies that have benefited the Earth and humanity for decades. We have created a variety of applications on Earth that have had a dual purpose and can also work here on terra firma. So some examples, we have done water and ocean filtration, our filtration technologies. We've worked on a variety of Earth monitoring activities, especially with some of the wildfires and checking our climate change activities, helping monitor crop growth for farming. A variety of new innovations in communications and powerless tools and so many different areas. NASA helps and kind of pays back the investment that the American people make into our space program. We are trying to create a robust and inclusive space economy. And we're doing that by partnering with industry to enable and help fulfill NASA's missions. We are leaning on commercial space to lead the way in some activities and use their know-how to help create new capabilities and missions for NASA. And we are working with international partnerships, space agencies, and peaceful scientific-minded people around the world in trying to collaborate to benefit our species. So now I'm going to turn it over to Max Briggs, and he's going to talk about how entrepreneurs and NASA help each other. So Max, I'll turn it over to you.
Thank you, Greg. Yeah, I wanted to, as Greg said, we partner with industry all the time in NASA. There's lots of different groups within industry that we partner with. I am specifically going to talk about how entrepreneurs and NASA can help each other. And I really do think that that's important, not just for NASA to be a consumer of innovation, but also to be a cultivator of innovation. And so the back and forth between in that relationship is crucial. Greg, could you go to the next slide, please? Thank you. So to understand how NASA and entrepreneurs can successfully work together, we first have to understand how NASA uses technology. When NASA uses technology in order to accomplish its mission objectives, we call it infusion. In this process, NASA typically funds the development of the technology, but eventually becomes a customer for the technology. And this is great for NASA, but since NASA has some very niche needs, and we don't typically provide a massive demand all on our own, technologies that target infusion don't always attract the entrepreneurial community. But that's not the only reason we fund technology development. In some cases, NASA is responsible for direct market stimulation or for developing technologies for both government and private sector use. For example, the Aeronautics Research Mission Directorate at NASA does not have mission goals in the same sense that science or human exploration does. Their mission is to stimulate emerging markets like advanced air mobility and hybrid electric aircraft. This happens on the space side too, with programs like low Earth orbit commercialization, which is responsible for developing technologies that will create markets and business models. These applications can be more attractive to entrepreneurs because the potential market goes beyond NASA. Although a substantial portion of the technologies that NASA invests in are along the lines of infusion, the remainder of my talk is going to focus on market stimulation and dual use technologies that can be more attractive for entrepreneurs. Next slide, please. So not everyone thinks of NASA as an organization that's responsible for market stimulation. But as Greg said, it's actually been a mandate of the agency since its inception and lives on to this day in many of the strategic priorities from the Space Technology Mission Directorate, which is who I stole these slides from. For example, STMD the STMD strategy specifically calls out delivering innovations that improve capability for NASA and the nation. And the nation is a crucial part of that sentence. Investing in traditional and emerging aerospace business by creating markets and spurring innovation, again, creating markets, and engaging the brightest minds from academia and small business. These are direct references to the NASA goals of market stimulation, dual-use tech development, and community building as STMD objectives, not necessarily things that are more commonly thought of as NASA objectives like boots on the moon or taking pictures of deep space. Next slide, please. To drive it home further, we can look at STMD's 6 strategic thrusts. One of those specifically calls out growing and utilizing the U.S. industrial and academic base. We can see that NASA has several goals that are not necessarily directly associated with what is typically considered a goal of NASA. Our goals do include market stimulation and advancing technology for both private sector and government use. Next slide, please. So NASA clearly has a responsibility to stimulate emerging aerospace markets, and these markets are clearly of interest to entrepreneurs. But what is NASA doing to make it work? Next slide, please. One example is the SBIR program. In this program, small businesses are asked to submit innovative ideas to a wide range of NASA technical challenges. Companies who are awarded contracts go through a 3-phase process that allows them to take ideas from the back of a napkin to a functional prototype and beyond. The SBIR program does not take equity in companies that it invests in. It provides early stage, non-dilutive capital to firms that have ideas that can solve NASA problems. At the end of a successful phase 2, the goal is either to infuse the technology into a mission or to use post-phase 2 mechanisms to get that matched funding mechanisms to get those technologies into the hands of a commercial market. Next slide, please. The SBIR program has created several examples of infusion. This chart shows several technologies, companies, SBIR companies that have contributed to the Perseverance rover. Next chart, please. But we also see that several of the companies did not just target an application on the Perseverance rover. For example, Air Squared developed a scroll compressor that's used in medical and fuel cell applications. ATI Industrial Automation qualified a load cell that was used on Earth for applications on the surface of Mars. And Photon Systems Inc. was able to use a deep UV laser intended for terrestrial wastewater testing in order to test for signs of ancient life on Mars. Next slide, please. NASA also seeks solutions from the entrepreneurial community through programs like Science Mission Directorate's Entrepreneurs Challenge and NASA iTech. These programs focus on attracting companies whose primary goal is selling into the commercial market, but could benefit from early stage networking opportunities, funding, or an anchor customer at NASA. For example, one company identified it through the Science Mission Directorate's Entrepreneurs Challenge is Mobile Ion. The company focused on mass spectroscopy solutions for disease detection and diagnosis in medical applications here on Earth, but found that their technology could enhance the Science Mission Directorate's ability to collect samples for planetary life detection. Another example from NASA iTech is Dimer, a company that partnered with Honeywell to provide between-flight cabin disinfection solutions for commercial aircraft cabins. Not only is that commercial market directly relevant to the goals of the Aeronautics Research Mission Directorate, but it could potentially also aid autonomous cleaning in long-term habitats in space. Next slide, please. For those that are interested, NASA iTech currently has an open solicitation that closes October 15th. The focus areas include enabling technologies for commercialization in low Earth orbit, hybrid electric aircraft, physics-constrained machine learning and AI, and climate resilience through application of NASA data, and an X factor category for game-changing innovations that NASA may not even know to ask for. I encourage anybody in the audience who thinks that they may have an innovation that can cover a commercial market, but also is applicable to NASA, to apply and come talk to us. Thank you, Greg.
Thank you very much, Max. And next, we're going to turn it over to Dionne Hernandez-Lugo, who'll give us some insights on the Artemis program.
Thank you very much, Greg. So today we're going to talk a little bit about what the HEO, Human Exploration Mission Directorate, is doing related to working with partners and how we're going about establishing our Artemis base on the moon. Next slide. So over the last decade, we've basically transformed the way we work with private industry from an old approach of just NASA managing a lot of contracts to having independent companies be competitive to provide services, in which NASA would be just one of those customers. We are extending successful LEO models to the moon, buying elements or services through competitive, innovative procurements. One of those being the Next Step BAA, which is a public-private partnership model, which is a competitive developing leading to a private sector to have capabilities that we can buy on the market. This approach would allow industry to be more innovative as well as cost effective. some novel approaches of creating a competitive market. That's another way to approach solving big problems. Having many options on the table helps us understand the full spectrum of capabilities that may be out there in industry, and it opens doors to combining skills across multiple vendors. This then turns into having, a team with an unexpected teaming leading some of these development. For example, one place where we could see cross-discipline teaming, it's in our lunar terrain vehicle. This is a place where you could have space companies with other industry partners. For example, you could think about maybe having automotive industries that can look at state-of-the-art electric vehicle capabilities, working together with space industry, which understand the space environment. Next slide. So how we're going about building industry capability. So for this, we work very close with SMD and STMD. And the idea is to have, in order to have a competitive market, we want to be able to have success cases. NASA must provide some expertise, facilities, and guide companies along the way to establish capabilities that are reliable enough to meet our safety standard and mission objectives. So here you have two examples where we use commercial needs, but didn't necessarily have a specific use cases for them. So one of them was the Lunar Catalyst. This was no funds exchange Space Act agreement, where you had 3 companies that help develop capabilities to deliver payloads to the lunar surface. By the end of this partnership, NASA had issued what we now call the Commercial Lunar Payload Services, the CLPS. And here they had a selection of about 14 companies. And some of you may know some of these companies. For example, Mastin and Astrobotic are 2 companies that came out of this development who are flying in the next 2 years to the moon. Now, next step is a public-private partnership model that seeks commercial development for deep space exploration to support human spaceflight mission. In most cases, you have cost sharing. So private companies have the opportunity to incorporate human surface capabilities into their portfolio and seek a customer base beyond just NASA. So these are just 2 examples of how NASA was able to develop private sector capabilities at a low cost to the agency and gain a more competition in the emerging market. Next slide. So here is just a picture or a map of how we're going about a capabilities integration. So we are in the process actually in the agency of realigning our gaps with the architecture that we have for the moon and later for Mars. And the intent is to publish a list of these capabilities later this year so that industry, academia, and other potential providers can begin to propose and let us know ways they, innovative way that they would address those. So some of these largest gaps will be identified, like I mentioned before, the next step BAA on gaps such as habitation and landing on the moon. Next slide. So how do you become a partner? So NASA has been working very heavily to connect with the science and the technical community. And the way we're doing that is through these three organizations that we have here. So SURVEY is very science specific. And it was out of SMD and now it's out of HEO, but we do work together with SMD together with this organization. On the technical sides, we've had the Lunar Surface Innovation Consortium, which is out of STMD. And then we also have Trish. So all the information is there as well as the links for you all to be able to get more information on how to actually be part of these and become a partner with NASA. Next slide. And for the students out there, we do have a lot of opportunities for students, starting with internships as well as fellowships that students can apply to be able to work with some of our engineers and scientists here at NASA centers. So we do have a variety of those starting from high school. So you could actually become an intern when you're in high school, all the way to graduate school. By the way, this is how I was able to work for NASA. It's by taking advantage of this. So it works. Next slide. And so NASA Solve, so NASA, you know, we have some difficult challenges to tackle out there. So through NASA Solve, what we do is we bring together a large number of individuals to help solve specific problems. And the difference between this one and the other ones that I spoke about is that we use basically the general public to solve different problems that we may have. There's a potential winning prizes as a result of this work. So specific project listed on the site that you all can go to. And then this helps engage people in problem solving, including areas such as crowdsourced challenges, prize competition, citizen science projects, and then competitions aimed to advancing student education. So with NASA Solve, we bring the public in for their innovative ideas to help solve problems in space, aeronautics, and earth science research. So like I said, for more information, you could go to the website. And my last slide is on how we're working together with other countries to be able to go back to the moon. So in order for NASA to comply to what is known as the Treaty on Principles Governing Activities of Space Exploration, so we do want to go to space and we want to do it peacefully, right? So that's what the Artemis Accords kind of does. It brings NASA together with 12 other organizations and countries who have signed this Artemis Accord. And the accord establishes a common vision via a practical set of principles, guidelines, and best practices to enhance the governance of civil exploration and the use of outer space as we advance the Artemis program, but in a peaceful way. So thank you very much.
Thank you very much, Dionne. Next, we're going to have Nicki Rayl speak a little bit about the great and exciting activities going on in our Science Mission Directorate.
Thank you, Greg and Dionne. All right, yeah, I'm hoping to give you just a brief overview of what we're doing in science, ways to engage. We desperately need your help as we plan future missions and work to achieve our science goals. If you wouldn't mind flipping to the next chart, Greg. So we have 3 key science themes that drive all of our activities in science. That's protecting and improving life on Earth and in space, searching for life elsewhere beyond our home planet, and discovering the secrets of the universe. And this drives everything we do, all of our mission planning and all of our future activities. Next chart, please, Greg. So to achieve those kind of overarching science goal areas, we're organized in disciplines. And this is only as important as if there's a specific interest that you have that aligns with one of these disciplines, so you can look to which one might be of best interest to you. So we have earth science, focused on our home planet, heliophysics, studying the sun, planetary science, looking up and out to distant destinations, and also including the moon, astrophysics, looking at more of a fundamental physics viewpoint of the universe, biological and physical science, looking at fundamental biology and also fundamental physical science elements of research, and our joint agency satellite division that kind of helps us collaborate with other agencies and coordinate some of the very vast amount of assets, satellite assets that we have in orbit, and coordination with other federal agencies as well. Next chart, please. I want to give you just a snapshot of where we're doing research. This is our science fleet graphic that we update very frequently of where we have studies going on or studies getting ready to launch, and also some of our partner coordinated activities. So you can see we are really working in a huge variety of environments. From we have a ton Earth-based activities and in low Earth orbit and space station, developing activities for the moon, sun, deep space applications, and Mars. So we're really kind of have a little bit of research going on everywhere at any given time, and upcoming missions that will be going to some deep space missions as well in the coming years. Next chart, please. So we are organized around a scientific vision that was released in 2020 to lead, a really interconnected program of discoveries to encourage innovation and positively impact lives on Earth. The mission, as I mentioned, was those 3 kind of organizing principles before, And we work around specific values of excellence, inclusion, and teamwork. And these, you know, it's great to have this on the chart, but we really mean this. And you'll see the driving force behind our science program is really teamwork, partnering, and how we develop those connectivity through partnerships to develop our technology and to develop our science. Next chart, please. So how do we, you know, one of the ways, the primary way we actually interact with academic institutions and industry is through our research solicitations. We release either announcements of opportunity for major missions, like to build something to go to Venus, or even for small satellites and instruments. The tool we use is called our Research Opportunities in Space and Earth Science, or ROSES. It comes out every year on Valentine's Day. You can remember it's roses. There are numerous appendices under this, where every single division that I mentioned has an appendix where they release science content. We also have a cross-cutting element. And so if you're interested in kind of our pipeline for how to get NASA funding, how to partner with us on missions, this is like our primary source. We in science are driven by extramurally competed science through universities and academic institutions, as well as industry. This is kind of our, you know, our life's work of how we fund research. Next chart, please. Another element, of course, that's really important to us of getting, you know, innovation, developing the next generation of our workforce is through our student opportunities. Dionne mentioned there's great opportunities and general websites. We also have some specific areas within science, from, you know, high school programs, be it, you know, bioinformatics or hands-on lab experience, undergraduate research opportunities, and postdocs. And we truly seek to spend a significant amount of our funding each year bringing students into our pipeline and really giving meaningful hands-on laboratory experiences for those that are, you know, science or engineering minded, as well as opportunities in, you know, international partnerships and policy. And for folks that, you know, maybe want to be on more of the policy or mission support end of things. Next chart, please. We also have a citizen science activity, which it's been mind-blowing to me how many discoveries have been made and data has been processed by citizen scientists, students, people that just have an interest in it. We have 23 online projects to kind of assist our science teams in finding new discoveries, writing publications, and you can do things like mapping the ocean floor, discovering new planets outside of our solar system, classifying auroras in our sky, as well as looking for asteroids, and so many more things. And this is a fun thing to kind of poke around and to give you a sense of, like, what does the data stream look like that's coming in? What do we do with that data after a major mission, and how do we make something meaningful of it? And we'd love to have anyone that's interested participating in this. Next slide. Next, yeah. And then in the technology area, this is where we probably focus our energy on more, you know, entrepreneurial startups, smaller companies, as well as universities that are just kind of starting in the, you know, NASA research proposal environment. Max was kind enough to mention our Entrepreneurs Challenge that we release as a way to get, you know, kind of concepts for next generation technology development and get startups engaged in what sometimes can be kind of a tough bureaucratic NASA environment to break into sometimes when you look at, you know, proposing for government research funding. Also in this area, though, we have technology funding for instrument development across all of our divisions. And, you know, from Nancy Grace Roman Telescope to our Pioneers program to really robust amounts of funding available in Earth and planetary science for sensor and instrument development that would then likely plug into a major mission to get tested or developed. And this is a great way to kind of, you know, put your toe in the water if you're interested in NASA funding and if you're interested in starting to develop, you know, proposals for future funding. And unfortunately, we're off cycle for Entrepreneurs Challenge, but that's also a fantastic opportunity. You can see underneath this website as well for a little bit more handholding as far as what does it mean to, you know, do research in space? What are the constraints? What are the operational needs? Like, what does rad hardening, you know, hardware and software mean when it comes to protecting things from the radiation environment of space? So we really see this as kind of a guiding force of the missions of the future. And we really need your help in how we can define missions, be it through student programs or through technology development to accomplish the needs of the future. Next chart, please. And lastly, I just want to say, technology and risk are some things that really drive our science. We want to include a new technology, which means taking on some risk in every mission that we fly. We know that measured risk taking and huge advances in innovation are what drive our scientific discovery program, and we need your help to do that. We within NASA and its science in particular really feel strongly that the extramural community is how we want to develop our science, develop the science of the future, and develop our technology of the future. And we seek to engage with partners on that at all ends of the spectrum. And I hope if there's any, hopefully you'll check out some of these websites and see ways that you might be able to participate. And I know we'll be able to take pictures at the end. All right, or take questions at the end. Sorry, I was reading Max's question. That's it. I think that's it for me. Yeah, thank you so much for your time on a Friday morning.
Yeah. Nicki, thank you very much. So next, Ken Wright is going to talk about the importance of partnerships with some of NASA's innovation activities.
Thanks, Greg, and thanks everyone for joining us. So yeah, I'm Ken Wright. I'm the Innovation Lead in the Office of Chief Technologist at NASA headquarters. And you've heard from all of the previous folks here at NASA that innovation is not optional. In order for us to achieve our missions, this is something that's very important throughout the agency. And so one of the things we were tasked to do was to develop the innovation framework for the agency. Next slide, Greg. One of the things that happened a few years ago, there was a study done to look at NASA and said there's still some things out there that prohibit us from being as innovative as we could be. And this is just some of the key aspects of that in terms of risk-averse culture, short-term focus, instability because of the changing times, lack of opportunities, process overload, communication challenges. In a large agency, it's a lot of different moving parts, and a lot of times it's hard to communicate effectively among the different aspects of the agency. And then just like a large aircraft carrier, you have the organizational inertia, things that take a long time for us to be adaptive to change. So one of the things that we were looking at is what can we do to overcome some of these barriers to innovation? Next slide, please. So the National Academies of Science actually helped us in terms of creating a workshop that was focused on the continuous improvement of NASA's innovation ecosystem. They brought in experts from industry, academia, government innovation leaders, and it was really focused on helping NASA to identify actionable and implementable initiatives that could really help sustain and actually improve the pace of innovation at NASA, and actually look at the overall culture of innovation to help us reach our future state where we can be even evolving more in terms of adaptability and innovation in general. Next slide, please. One of the key things that came out of that particular workshop was the fact that innovation meant a lot of different things to a lot of different people. We've heard that from all of the previous folks on the panel. And one of the things we wanted to do was come up with a tagline for innovation from a NASA perspective. And we came up with transforming diverse ideas into value, where it's not just about getting ideas from our traditional sources, but expanding that to non-traditional sources, and not just having ideas, but ideas that are focused on the value proposition for the agency. And I think you've heard that from Max and Nicole and Dionne in terms of their initiatives, where they're really looking to expand the ideas and making sure that the folks with the ideas have a clear feel for what the challenges are that NASA's facing as well. One of the key things about innovation is it's not just about the technology, it's also about our people, our risk portfolio, our innovative partnering, and our innovative practices. And you see partnering is a key aspect of that innovation that we really have to continue to work through. And one of the key things that we want to talk to you about today. Next slide, please. One of the key things that we wanted to do was just developing this innovation framework, which is kind of 5 top-level steps that are involved with the innovation process to, again, make it more intentional. It starts with clarifying the need in a way that can diversify the ideas that are associated with that particular challenge. I love the example that people give on this one associated with the potato chip industry. I know you say NASA and potato chips, what they have to do with each other, but in the potato chip industry, there was a problem with potato chips where the chips would break to get the grease off the chips, because the chips actually had to be shaken in order to get that grease off. But we like big chips, but we like non-greasy chips. So they did an open source challenge and crowdsourced and said, hey, how do you get grease off potato chips? Most of the answers that came in were not very novel, because people were responding only who were in the potato chip industry. And so that involved some form of shaking. Then they repurposed the challenge and defined it as, how do you get a viscous fluid off of a delicate wafer? Nothing relevant to potato chips in that particular problem statement. And because of that, they got all types of novel ideas of how you could get grease off potato chips. Ended up, they use a method found from the violin industry in terms of how to get rosin off the violin strings. And that's actually by generating an acoustic signature at the resonant frequency of the grease, and the grease just pops right off the chips. So in our innovation framework, one of the things we're working with the mission directorates on is, how do you couch these problems in a way that diversifies the ideas that potentially could address them? And then once you do that, how do you even connect with the broad ecosystem of people and places that could contribute to addressing that challenge? There's lots of information, of course, on the web. We're always looking at AI, ML techniques, as well as natural language processing, and trying to incorporate that into NASA systems to be able to reach out and identify potential partnering opportunities. Then working with the folks in that ecosystem to define that future state, because we found it's really key to continuously improve if you have the ability to not just look at your near-term objectives, but also longer term. And then be able to move out quickly and develop innovation experiments and share lessons learned from those experiments, not just when you achieve the results that you expect, but also sharing the results when you don't get the results that you expect. Next slide, please. So what is the innovation ecosystem? You know, it's about having the ability to work together as a community to address various challenges that we're facing. And one of the things that we've developed is this concept called Ideas to Value sessions, or I2V sessions. And this includes things that you've already heard about today, including the crowdsourcing, the hackathons, pitch days. All those types of methodologies are there to diversify the group who potentially could address NASA's challenges, and provide people, the challenge owners, with a methodology to connect directly to the folks with the ideas. Next slide, please. We talked a little bit about future state before. This example kind of shows the importance of being able to focus on that future state as you're working through the problem. On the left, you see a graph that shows value on the vertical axis and time on the horizontal axis. An example is with PCs. You know, there was a lot of work on PCs focused on, you have a PC, how do you make it faster? How do you make it smaller? How do you make it more portable? But each time you made those changes, the value proposition actually went back down dramatically, because the competition was also working in that same realm. You contrast that on the right with the methodology used by Apple a lot of times in terms of looking at the future state. So when they were looking at the iMac, they weren't just thinking about a smaller iMac or a faster iMac. They had the idea of eye health already in mind. And then the value proposition actually was maintained a lot higher, because their production and their experiments and the work that they were doing was always working towards getting to that eye health model. So you saw things like the iPhone and iPad and iWatch that ultimately are focused on achieving that eye health model. And these types of things are activities that we like to work with our partners on more closely in terms of the future state piece, and being able to involve all the stakeholders as we move forward to help us sustain the leadership and leverage the experiments that will allow us to achieve those future states. Next slide, please. And then one of the key things that we're looking is, how do we focus on well-designed innovation experiments? And a lot of times you hear about pilot programs or things that happen, but the difference with experiments and pilots is that there's an emphasis on learning in terms of experiments. And designing well-designed experiments actually help you learn tremendously. And the idea here is to increase the pace of learning and identify the fastest path to maximum value for the agency. And of course, this should not just be experiments in the technology area, but how do we experiment with ways to connect to our partners more effectively? And so that's, again, some things that we'll be doing, and I think you've heard a lot of those already, and expect to hear more of those in NASA's future in terms of how we can connect to you as a broader source of ideas for NASA challenges. We also want to reward failure. You know, a lot of times you get a NASA contract and you only consider success if you meet your objectives. But in some parts of the agency, we really want to have those high risk, high return activities where you can get rewarded even if you fail, but you share lessons learned and you learn a lot from those particular experiments. So again, that's kind of an out of the box concept that we're still looking at developing. Next slide, please. So that's it. You know, we just wanted to make sure that you had a feel for the agency perspective on innovation and some of the key steps that are associated with that. And with that, I'll turn it back over to you, Greg.
Ken, thank you very much. Before we open it up for questions, we just wanted to share that we have a partnership office within NASA, and they are kind of charged with figuring out ways to collaborate with institutions, with industry, with academia across the country to address a variety of NASA needs. Every single center and facility has a partnership point of contact. And at that website provided there is a link. And if you are close to a NASA center, please reach out, figure out how you can get involved and figure out ways that we could work together. Because you know, the space program belongs to everybody, all citizens, and together we can succeed and be even more successful in the future. And we need help. We need all the new ideas, the bright energy, the innovations, and the drive and determination of our citizenry to help make the world and a better place. So thank you for listening today. And we wanted to open it up for, see if anyone had any questions.
Yes, we have a couple of questions in the Q&A.
Okay.
The first one is from Rose Crozier, and her question is, does NASA ever advise emerging space partners re-access to use of space? I mean, more than encouraging STEM via academic community, has NASA been asked to advise countries' effort to develop a holistic approach to their own space ambitions long term?
Let's see, did anyone want to take a cut at that answer?
I mean, I can, I don't know that I can answer it well, but so I can say that as part of the entrepreneurial engagement activities I've been involved with in the past, we released an RFI, and this question or some version of it comes up fairly often, which is kind of, you know, NASA has a lot of expertise operating in space and has a lot of knowledge of gaps that exist and some of the difficulties. And so what can NASA offer to somebody, a company who's trying to get into emerging space markets in terms of vision? This question comes up with investors a lot in terms of, you know, they want to know what are their true choke points for, like, what's really preventing us from getting, is it launch costs? Is it comms? Is it power? Is a scarce power environment? So what are the things that we really need? And how can NASA be a thought leader in that space? And I think NASA does release documents, several strategic documents that kind of lay out a vision for space and commercial space. But I don't know that we do a great job, or as good a job as we could, of vocalizing those in a really digestible way. And so I mean, you can go on and see some of the strategic documents. You can go onto Leo Commercialization's website, for instance, and they have roadmaps for what need to be done. And I think that does have a lot of the information you're requesting in it. But I think that we could do a better job of vocalizing those, or getting people to you know, people who are not necessarily familiar with how to dig through the NASA the 150-page strategic documents, to get them something that they can see in a quicker format.
And on the in the international front of that, we definitely do, you know, participate and collaborate when our partners need support or advice. It goes both ways. You know, does NASA need help with the technology, or is an up and coming space agency want to see how we're organized and what our, you know, principles are around a specific science discipline? We definitely kind of support and advise our partner space agencies, be it through station or through mission work, and that is very prevalent, and as well as the up and coming space agencies that have kind of come to collaborate with us through the Artemis Accords, as Dionne mentioned, or through other venues. That happens pretty regularly and usually is kind of organized at the agency to agency level, but it is definitely occurring, and something that within science we support regularly on science definition and how we can contribute to, you know, a new agency or an agency's new science goals.
Thank you, Max and Nicki. I think that covered that very well.
We have another question also from Rose Crocier. Are you aware if other space agencies, ESA, for example, have similar programs to SBIR?
Max, you want to take that again? You want me to jump in?
Sorry, I just got kicked out of the meeting momentarily and just got back in. This is the SBIR question. I had read the question.
Yeah.
Okay.
Yeah.
Unfortunately, I actually do not know if ESA specifically has an SBIR equivalent program, but I do know that the SBIR program, so the SBIR program is not a NASA specific program. The SBIR program is across all federal agencies that spend at least a certain amount of money in R&D. And so USDA, DOD, Department of Energy, they all have their own SBIR programs. And several of them are focused directly on emerging markets. Several of them are focused on like mission activities, like DOD wants things for their missions. But in either case, I can say that the SBIR program has been looked on favorably by other countries. And so I know that other countries have copied the model of SBIR. I don't know if ESA specifically does it, but there are other European agencies that have. I would be surprised if ESA does not.
Yeah, I think so. I've interacted a little bit with them, and they have two programs that are the closest equivalent. The Business Applications Program under Space Solutions, which is kind of SBIR equivalent, and also their Technology Research Program. And they, when we interact, kind of categorize those as their small business research programs. As Max said, most agencies are doing this; they just have different names. But those are the two categories that I'm familiar with within the European Space Agency for this.
Okay, we have another question from Mike Rand. Do you see NASA being increasingly involved with international cooperative space regulation? Are there any frameworks to approach government's increased interest in space development?
Maybe I could start with the answer, and maybe my esteemed colleagues can add. We are very much wanting to collaborate in space. So, we established an outer space treaty a long time ago. The Artemis Accords is kind of the modern interpretation of that. We need to work together so everyone can benefit from our abilities to access space. We have to work together on challenges such as our climate change, such as the space debris that is in low Earth orbit to allow everybody's satellites to operate effectively. Even in gaining knowledge, NASA shares their knowledge as well as the rest of the scientific community. That's why NASA satellites that are observing the Earth, knowing the mission of NASA, we're allowed to fly over all countries of the world, even ones where our military is not welcome to be involved. So I think we do work together, and we strive to continue to work together. And as more opportunities exist in space, as there is more access into space, especially with the exciting new, developments in, space tourism that are emerging this year, it's going to be all the more important to collaborate. And I do see a very bright future, and NASA is one, you could say, of the anchor tenants, but there's many other organizations that are involved in accessing space. And I think we will work together, and I think there's going to be a lot more visible collaboration in the years to come.
At the very top level, there's the UN Office for Outer Space Affairs, which is kind of like the top treaty level strategic planning that all of the UN associated countries are partnering in, that NASA participates with. As Greg mentioned, there's a near-term need in orbital debris. There's so many satellites up there, it's becoming space trash, and how we're going to handle that as an international community. The human spaceflight sector, has really piloted or been at the forefront of developing policy around safety standards and regulations for human spacecraft, and how we all internationally adhere to those if we want to, say, visit the space station or the future of Artemis and the moon. I think there's so many policy questions out there as we become more of a spacefaring global community, so many more policy implications as more countries are participating in the sector, and as commercial ramps up. And there's many efforts underway, like you heard about the Artemis Accords, the safety regulations, but there's a ton of work to be done here. And I know under this UN umbrella, some of those discussions are happening, and they're also very much happening at the agency to agency level, and it's happening right now, and it's very much in development. And we are excited about the situation now that so many more countries and so many more commercial companies are participating in spaceflight. It's no longer a select few countries around the world and a select few government contractors. So it's an exciting problem to have, but it's definitely a daunting task ahead as all the policy implications of the lunar surface or the Martian surface are sorted out as we move forward.
Yeah, that's a good point, Nicki, too. And I know when I was over at also Science and Technology Policy, one of the assignments I had was to develop a document about how we protect and preserve the Apollo lunar artifacts. And with that, it was a really delicate balance between the commercialization side and really leveraging all the new opportunities in space. And at the same time, really looking at planetary protection. A lot of times we think of planetary protection as just being something for Earth, but also we need to protect the other planets and other solar system bodies that we visit. So it's a really delicate balance that has been really difficult as you get more and more spacefaring nations. And I think that's one of the reasons that we really haven't had a space treaty per se since like 1967, I think it was, when the International Space Treaty was last signed. So it's one of those things that we continuously work on. And I think the Artemis Accords is a good step along the way, because that's what it's going to really take in terms of collaboration and working together in a manner that really takes more than just our lives here on Earth into account. And I see the question from Mike about China. I know there's some discussions with China at different times, and that's one of the things that space is one of those areas. Hopefully we can break down some of the boundaries across nations, and when you have competition in other areas, it's been we've seen that with the International Space Station, where you can function across those boundaries at some point. So, but I know some difficult challenges out there because of other restrictions as well. So we'll leave it at that.
Well, can answer the last question about referencing China. I'm not sure if anybody wants to also jump in that question. Let me read it again. At the same time we pursue cooperation, is there a balance between such cooperation versus political military competition? For example, to what extent can or would NASA cooperate with China?
I think Ken did a good job of explaining it, honestly. I mean, the only thing, there are restrictions on which countries you can and can't deal with, or what processes you have to use in order to deal with specific countries. But I think Ken's example of ISS and partnering with Russia on ISS, even during some times where that has been a contentious relationship in the political sphere. Science is an area where people can come together for a common cause. And so I don't pretend to know what the future holds in terms of collaboration, but I think that there is some potential for space to be considered something that we do as a human civilization rather than as a country with a specific interest.
Sort of like Starfleet. Maybe we'll get there. Hopefully we will.
Hopefully we will indeed. Well, I don't see any more questions. Do you have any closing remarks or anything?
I guess what I would like to kind of leave this panel with is that, everyone can get involved in our space program. Students, entrepreneurs, technical professionals, just interested citizenry, anyone can be involved. And we would welcome new ideas and new solution providers to help us address the just incredible set of challenges and responsibilities that are placed on the space agency. We have so many different simultaneous goals that, really we need the best and brightest that the world has to offer. And, we'd love to be able to draw upon more and more people to help participate in helping NASA achieve our goals. So please get involved if you're interested. We'd welcome the help.
Thank you, Greg. Thank you, everyone. This was a great panel. I think the audience really enjoyed it. So thank you very much for being here. Great presentation.
Thank you for having us.
Yep. Appreciate it.
Thank you all.
Thank
Have a
you.
great day.
Bye-bye.
Have a good weekend. Take care.